The final topic, which is not covered in the book, is bimodal failure. So here's the notion. There are occasions where there are two modes of failure, failure by open and failure by short. So the old notation which we have worked with so far is P sub I is the probability that component I is functioning, which means that 1 minus P sub I is the probability that component I has failed. With the new notation, it turns out that P sub I remains the probability that component I is functioning, but now there are two different ways that an item can fail, and that's why they call it bimodal failure. And one way is failure by open, and failure by open has a probability QIO. And then failure by short is QIS. And if you take those two pieces and add them together, that corresponds to, in the old world where we just had binary assumption, they correspond to 1 minus P sub I. Notice that with both the old notation and with the new notation, you still have to specify a time t0. So you still say something like the 1,000 hour reliability is 0.8. Down here, you still specify the time t0, and you would say the 1,000 hour reliability is 0.8. The 1,000 hour probability of failing by open is 0.15, and the 1,000 hour probability of failing by short is 0.05. The words open and short for the two different types of failures come from electrical engineering, where you have things like short circuits, so that's the origin of the terms. Three examples will illustrate bimodal failure, and these come from electrical engineering. We're going to look at diodes. They come from mechanical engineering, where we look at springs. And then they come from what you might call systems engineering, where it's neither electrical nor mechanical, and we'll look at it in the medical world. So let's start out with example one, which is a diode. So what you do is you assume that current flows from left to right for a single diode, so current flows in this direction. And the purpose of an individual diode means that you have zero resistance in the forward direction, and that's what allows current to flow in this direction. And you have infinite resistance in the backward direction. But there are two different ways that a diode can fail. The first way is it can fail by open. And this is the symbol that's oftentimes associated with failure by open. And what you have is you have infinite resistance in both directions. Current cannot flow from right to left or from left to right, and that is failure by open. Second type of failure in a bimodal setting is failure by short, and you could draw such a system by simply having a line here which says you have zero resistance in this direction, but you also have zero resistance in that direction, and that's referred to as failure by short or a short circuit. The reliability diode is influenced by all kinds of other factors, such as the encapsulating procedure, operating temperature, the percent of its capacity that it is operating at, etc. Now, our goal here is to try to configure this system to protect against failure by open or failure by short. It's a little bit trickier to protect against both, but at least you can try to protect against one. And the two ways that we're going to arrange these diodes is, first of all, we're going to put them into a series system, and that's the first picture, and then we're going to put them into a parallel system. And just two diodes are used in both of these, but you could certainly have 3 or 4 or 5 or however many you need in either a series arrangement or a parallel arrangement. So when you place them in series, what does it mean for the system to now fail by open? Well, it means that either this diode or that diode fails by open, and we're at increased risk of that happening. What happens for system failure by short? That means you have to have both diodes fail by short. So watch, if this second diode goes out, we can represent that by a line. This system right here is still operating because current can flow in this direction, but you have infinite resistance in this direction because this diode is still doing its thing. So by arranging them in series, we are protecting against failure by short. The second way to arrange a pair of diodes is to place them in parallel in this fashion. Now in this case, system failure by open. What happens if this diode, the first one up here, fails by open and looks like that? Well, we still have this diode, which is working fine, and so we are protecting ourselves against failure by open. On the other hand, if one of these diodes fails by short, let's say this one right here shorts out, now what we have is we have current flowing with zero resistance in this direction and also in that direction, so only one of them needs to go out, and we are at increased risk of failure by short. The second example is a spring, and here is a depiction of a spring that is handling a weight of some type. And so for an individual spring, failure by open means that the spring breaks. In other words, it just split in half. That happened maybe about 5 or 10 years ago. I took the car in because something didn't seem right, and the mechanic took me back, looked underneath the car with a flashlight, and there was the spring, and it was broken in two pieces. So sometimes that might be referred to as catastrophic failure. The other way that a spring can fail is failure by short, and that happens less catastrophically and suddenly, but that means over time this spring has lost its springiness and stiffens, and it's not doing what springs are supposed to do anymore. So our goal here is to try to configure this system in some manner to protect against failure by open or failure by short. And just like in the diode case, we're going to put together a series system of springs, and we're going to put together a parallel system of springs. So to put two springs in series, we just have spring number 1, which we place here, and we attach to it spring number 2. Now what's happening with system failure by open, that says if one or both of these springs fail by open, then the system fails. So in other words, if this spring breaks or this spring breaks, then the system fails. We're at increased risk for that because either one failing causes failure by open. And notice this picture here is depicting failure by open. The other thing that can happen is the system can fail by short. Now let's say spring number 1 fails short. That means spring number 1 has lost its springiness, but since spring number 2 is still working, we still have that springiness in terms of the weight that is able to move up and down. And so by placing them in this fashion, we're protecting against that particular failure mode. Second type of system here is you can have a parallel system of springs, and here is that parallel system. It's a little bit awkward for springs, but kind of works. Let's look at system failure by open. Let's say this spring right here breaks, catastrophic failure. That means that both springs have to fail by open for system failure by open, and we are actually being protected against failure by open. However, with this system here, You also have system failure by short. If one of these springs, let's say this one on the right here, spring number 2 loses its springiness, then the weight can't really move at all with this configuration, and we are at increased risk because all we need is one failure. So we've done an electrical system with the diodes, we've done a mechanical system with the springs, and here is one which is a little more abstract, no physical system here, medical tests. So this component right here represents a medical test. And what does functioning mean? That means the test correctly determined the state of the patient. So regardless if this is a blood test, x-ray, MRI, CAT scan, whatever, functioning means it correctly determines the state of the patient. Now there's two different failures here, and sometimes these are referred to as false negatives and false positives. But failure by open means that a sick person was determined to be healthy. Well, that's a bad failure because somebody is actually healthy and somebody is actually sick, whereas the test determines them to be healthy, and that means the sick person is not getting the treatment. Failure by short is not a great outcome either, because it means that a person is healthy and the test says that they are sick, which means you start treating, hopefully not with surgery, but you start treating either with pharmaceuticals or surgery, a healthy person when there's nothing wrong with them. So our goal in this case is to configure the system to protect against failure by open or failure by short, and you can pretty much guess what is going to happen. We're going to set up parallel systems and series systems. So in both cases, we now have two components, and there is the series arrangement, and here is the parallel arrangement. In the series arrangement, the doctor will take action if both of the tests are positive, which means they both indicate a problem. Well, what is system failure by open? It means that one or both of the tests fail by open, and this is an outcome that has us at increased risk. What does system failure by short mean here? It means that both tests fail by short, and we are actually protecting ourselves against this type of failure. Now, in the parallel system of tests, here is the thinking. The doctor will take action if one or both of the tests are positive. So in this case, the doctor is going to be a little more aggressive because the doctor doesn't need both of the tests to be positive, one or both. So you're going to see more activity here. What is system failure by open? That means that both tests fail by open, and this particular arrangement is protecting against this type of failure, whereas system failure by short means that one or both tests fail by short, and this one is placing us at increased risk. So there are three examples: electrical system with the diodes, a mechanical system with the springs, and finally a medical-based bimodal failure with the medical tests.